oxide.
Alright guys, this is a video on your Form 4 Chapter 4 tutorial number 4. So in this tutorial we will do a lot of questions that is focusing on group 17 of the periodic table. Yeah, so hopefully after this video lesson you have a better idea on how the question can be tested for your group 17. Okay, all right, so without further ado, let us kickstart with the lesson. So the first question is coming from SPM 2015. This is a past year question. So the question is mentioning that element X is located in the same group as chlorine. Okay, so from here what we know chlorine is in group 17. So since the element Y is located in the same group, so we know that element Y also coming from group 17. Okay, so which of the following is correct about element Y? So since we know element Y is in group 17, we will choose all the properties that is related to group 17. So answer A saying that it formed the ion which is Y plus. So Y plus, this is wrong because we know that group 17, they have 7 valence electron. So when you have 7 valence electron, in order to be stable, they will receive 1 valence electron to be octet, because when 7 plus 1, so you will get 8 valence electron. So when you have 8 valence electron, it is octet, which is stable. Alright, so when the substance receive electron, when the substance receive 1 electron, the charge should be negative. So you should get Y negative, not Y plus. Okay, so remember, when a neutral atom receive electron, it should form negative ion. Yeah. Alright, so answer A is wrong. B, it form basic oxide. Basic means alkaline. Basic means alkaline, which is wrong because we know group 17 is acidic. Group 1 is alkaline. Group 17 is acidic. So answer B is wrong. Yeah. So C, it exists as monoatomic. This is also wrong because when you see the word monoatomic, it's talking about group 18. When you see the word monoatomic, it's referred to group 18, but we are looking for group 17, so it's wrong. So the answer should be donkey. It has 7 valence electron. This is true because we know element Y is in group 17. Group 17 should has 7 valence electron. Yeah, so the answer is D. Okay, so we will continue with the next question. So for the next question, this is SPM 2011. Which element dissolved in water, you will produce a solution that can change blue litmus paper to red and then decolorize. So when you see blue litmus paper to red, which means that it is acidic. Okay, it's acidic. All right, and then the important keyword is this. There's another important keyword. So the important keyword is decolorize. Okay, so when the blue litmus paper change to red, so decolorize means all the red color will gone. So when red color gone, you will get white color. So this is actually a bleach. Okay, so actually when you see that the litmus paper decolorize means no more color. No more color is bleach. So in group 17, there are 2 important bleach you need to know, which is chlorine and bromine. Yeah, we learned this in the last lesson. Okay, chlorine and bromine, they are bleach. Okay, so 1 and 2. So this is very straightforward. Yeah. So next one, this is SPM 2012. This is SPM 2012 past year question. Which of the characteristic means properties. Characteristic means properties. Which properties is correct about group 17? Okay, when you going down the group. Okay, going down the group means go from top to bottom. So you go from, okay, fluorine to chlorine to bromine to iodine. So going down the group. Okay, so let's check. So answer A say that reactivity increases. So this is wrong. Group 17, going down the group become less and less reactive. Group 17, going down the group become less and less reactive. Okay, so A is wrong. B, intensity of color decreases. Intensity of color means what? How dark is the color? So going down the group, the color should become darker. Okay, going down the group, the color should become darker because fluorine is pale yellow, chlorine is greenish yellow, bromine is brown, iodine is purplish black. So going down the group, the color get darker. So when the color get darker, the intensity should increases. Okay, when the intensity increases means the color get darker, but they say decreases. So the answer is wrong. Okay, so C, the tendency to accept electron decreases. So going down the group become harder and harder to receive electron. This is correct. Why? We learned before, going down the group, we have more and more shells. Okay, going down the group, we have more and more shells. When we have more and more shells, now the electron is far away from nucleus. When electron is far away from nucleus, the nuclear attraction become weaker. So when nuclear attraction become weaker, it's very hard to attract. It's very hard to pull the electron. Okay, so the answer C is correct. The tendency to accept electron decreases. Okay? Because when you're going down the group, electron is far away from nucleus. So very hard for the nucleus to pull the electron already. So answer C is correct. Okay? So answer donkey, the physical state change from liquid to gas. This is wrong. Okay? Because when you're going down the group, the fluorine is pale yellow gas. Chlorine is greenish yellow gas, bromine is brown liquid, and iodine is purple black solid. So by right, going down the group, you change from gas to liquid to solid. But the question say liquid change to gas. That is wrong. Okay, so that's why the best answer is C. Okay, so next one. Alright, so this is SPM 2013. SPM 2013. So the question say that the boiling point of chlorine is lower than bromine. Okay, which statement best explain this phenomena? So remember, when the question asks about melting point or boiling point, your answer must talk about the force of attraction. Okay, your answer must talk about the force of attraction and also the heat. How much heat to overcome the force of attraction. Okay, every time when the question asks you to explain about melting point and boiling point, the answer should include force of attraction and also the heat. So let's see whether there is any answer related with force and heat or not. So that there is the answer. Yeah, there is the answer here. So you can see the donkey. The force of attraction between the chlorine molecule is weaker because we know that chlorine is smaller than bromine. This is chlorine and this is bromine. So when chlorine is smaller than bromine, so when chlorine hold their hand together, this is a weak van der Waals force. But when bromine, the size is larger. So when bromine hold their hand together, so this is a stronger van der Waals force. Okay, all right. So chlorine is smaller than the bromine, so the van der Waals force is weaker. Okay, so you have a weak force of attraction. So answer D is the most suitable one. Okay, so let's move on to another one more question. So for the subsequent question, this is SPM 2014. 2014, SPM 2014. So they ask you which characteristic is similar for group 17. So which one is group 17 properties? Number one, A, group 17 form colored ion. So does group 17 form colored ion? Nope. Okay, nope. Group 17, the color is not ion. The color is what? The gas, the liquid, the solid. Okay, because you have pale yellow gas, greenish yellow gas, okay, brown liquid, purplish black solid. So the one got color is referred to the solid, liquid and gas, not the ion. So the word ion here is wrong. B, it has high melting point and boiling point. Not really, yeah. Group 17, they are non-metals. Non-metals attracted by weak van der Waals force. So when they have weak van der Waals force, okay, when they have weak van der Waals force, okay, so the melting point and boiling point should be low, because when the force is weak, the boiling point and melting point is low. So B is wrong. C, they exist as gas at room temperature. Nope. Group 17, you have gas, you have liquid, and you have solid. Yeah, you can see just now, you have gas, you have liquid, you have solid. So not all the group 17, they are gas. Not really, yeah. Okay, so remember, group 17 is the one and only group that you have solid, liquid, and also gas. So the answer is donkey. So it dissolves in water to form acidic solution. Yes, group 17 is acidic. So when you take halogen to mix with water, you will form two acids. Okay, when you take halogen mixed with water, you form two acids. So that's why it is acidic. So the answer is donkey. Okay, so now we look at another one more question. This is SPM 2019. This is SPM 2019. Okay, this is one of the recent past year. Okay, so let's look at the question. So diagram 5 show you the group in the periodic table of element: fluorine, chlorine, bromine, iodine. So they are group 17. So we have group 17. So now this question is a little bit tricky. Normally the arrow should go down. Normally we should moving down the group. Okay, normally we should moving down the group, but now they moving up. So how to do? Everything terbalik. See, so everything will terbalik. Okay, so let's look at it. The first one, so will the density increases or not? Okay, will the density increases? Density is mass over volume. So when you're going up, okay, remember, going up, what happened to the mass and what happened to volume? We know going down, it become bigger and bigger, right? Going down, bigger and bigger. So the mass will increase. When mass increase, it become heavy, density will increase. This is when you're moving down. When you're moving up, everything terbalik, the density should decreases. Okay, the density should decrease, but now they say increase, so it's wrong. Okay, so here the tips very simple. You try to add another one more thing here like this. You add this thing, you moving down the group, you go for your trend and you terbalik to get it going up. That's it. Okay, so let me show you another one more. Let's look at answer B. The atomic size increases, correct or not? No. Going down, the group size become larger. So when you're going up the group, the size will become smaller. So the size should become smaller. So they say increases, so it's wrong. C, the boiling point will increase. Okay, so this is something we learn. Going down the group, the size will increase. When the size increase, van der Waals force will become stronger. Okay, when the size increase, the van der Waals force become stronger. Okay, when the van der Waals force becomes stronger, by right, when the force is stronger, melting and boiling point should increase. Okay, so this is when we moving down the group. When we moving up the group, terbalik. When we moving up the group, melting point and boiling point will decrease. Okay, should decrease lah. So they say increase, so it's wrong. So the answer is donkey. Reactivity increases. Okay, reactivity increases. This is true. We know group 17. We know for group 17, going down the group, it becomes less and less reactive. So if we terbalik, going up the group should be more and more reactive. Okay, going up should be more and more reactive. So more reactive means reactivity increases. So answer D is correct. Yeah. Okay, so let's move on to the next question. So the next question, which of the following is the correct change in the property of element when you're going down the group? Okay, all right, so going down the group 17, what happened? So when we have fluorine, chlorine, bromine, and iodine, going down the group, electronegativity decreases. Okay, so again, recall back, what is electronegativity? Okay, so if you want to be negative, you must receive electron. Okay, so always remember, okay, remember this. Okay, so electropositivity is actually the tendency to donate electron. Okay, when you donate electron, you will become positive ion. So electropositivity tell you who love to donate electron. Okay, so electronegativity, we will go the other way around. Okay, electronegativity, we go the other way around, terbalik. So electronegativity is the tendency to receive electron. Okay, because when the substance receive electron, it become negative ion. Okay, so always remember, something neutral donate electron, it become positive ion. So something neutral receive electron become negative ion. So if the substance love to donate electron, it is very electropositive. If the substance love to receive electron, it is very electronegative. So now look back the question. So the question say electronegativity decreases means what? Means harder to receive electron. Okay, harder to receive electron. So going down the group, harder to receive electron, correct or not? Okay, going down the group, harder to receive electron, is it correct? So I would say yes, because going down the group, let's say this is fluorine and this is iodine. Going down the group, the size is getting larger and larger. So when the size is getting larger and larger, okay, so the valence electron is far away from the nucleus. Okay, so the valence electron now is far away from the nucleus. So when valence electron is far away from nucleus, so the nucleus attraction, the nuclear attraction is very weak. So this nuclear attraction is very weak. So when nuclear attraction is very weak, it's very hard to pull one electron from outside to come in. Yeah. So it's very difficult to pull the electron to come in. Okay. So you see, going down the group, so the valence electron is far away from nucleus. When valence electron is far away from nucleus, so the force of attraction between the nucleus and the electron is very weak. Okay, this force of attraction called nuclear attraction. So when the nuclear attraction, it become weaker and weaker, so it become harder to receive electron. So when it's harder to receive electron, so it is less electronegative. Okay, so it becomes less electronegative, because electronegative means who can receive electron easily. Okay, so when it's hard to receive electron, it's less electronegative. So the answer A is correct. Yeah, the answer A is correct. Okay, if you're not sure, you can try answer B, C, and donkey. Boiling point decreases. No. For group 17, going down the group, the size will become larger and larger. When the size becomes larger, the force of attraction becomes stronger. When the force becomes stronger, so we need more and more heat. So more heat means melting and boiling point should increase. So the color get brighter. No, going down the group, the color become darker. So donkey, atomic size smaller. No, going down the group, we have more and more shells. When we have more shells, the size should get bigger. So answer B, C, and donkey all are wrong. Okay, so if you're not sure the answer is A, you cut the wrong answer. B, C, and donkey is wrong. So you will choose the answer A. That's it. Okay. So next one. This is question number 5. So the question say when we have element Q dissolved in water, so this element Q, they will form a solution which will bleach the litmus paper. So when you see bleach, you know two things already. Bleach must be chlorine or bromine. When you see bleach, it must be chlorine or bromine. So which group it belongs to? So we know chlorine and bromine, they belongs to group 17. Okay, so please remember this. When you see bleach, it must be chlorine or bromine, and we know chlorine, bromine, they are all in group 17. Okay, so next question. What is the meaning of electronegativity? So this is what I said just now. So negative. So negative means what? If you want to be negative, so you must receive electron. Okay, if you want to be negative, you need to receive electron. So we would go for receive electron. So here they don't use the word receive, they use the word attract. So attract electron, attract electron. So this is okay. Yeah. So now how to choose the answer B or donkey? So answer B say what? The ability of an ion to attract electron. Donkey, the ability of an atom to attract electron. So we should choose ion or atom. So remember, okay, we learned before, okay, before the substance donate or receive electron, they are neutral. Okay, look back to this one. Look back to something we learned before. Okay, so let me show you this. Okay, all right. So it's always starting with a neutral atom. So when something neutral donate electron, then they form positive ion. When something neutral, they receive electron, then you form negative ion. So everything start from a neutral atom. Okay, so it's always start from a neutral atom. Okay, so when we have a neutral atom, if this neutral atom can donate electron easily, so it is electropositive. When this neutral atom can receive electron easily, so it is electronegative. So no matter donate or receive electron, it all started with the neutral atom. So we must choose atom. So the answer is donkey. Yeah. So next one, which is the characteristic for all the element in group 17? So group 17, which one is true? Number 1, it form complex ion. Nope, we never learned this before. Yeah, we never learned that group 17 can form complex ion. Nope. High melting point and boiling point, this is wrong. Group 17, they are non-metals. So non-metals attracted by weak van der Waals force. So since the force is weak, the melting and boiling point should be low. C, it dissolves in water to form acidic solution. Yes, group 17 is acidic. Alright, remember, group 1 is alkaline. That's why we call it alkali metal. Group 17 terbalik. Okay, group 17 always terbalik from group 1. So when group 1 is alkaline, group 17 terbalik, it is acidic. So answer C is, okay, answer C, they say dissolve in water to form the acidic solution is okay. But many students, they will say, sir, answer donkey also seems correct. What? They exist as diatomic. Yeah, group 17 always come in diatomic, always come in 2 atoms like Cl2, Br2, I2. Seems okay, what? But why we cannot choose answer donkey? Why we cannot choose answer donkey, although they come in 2 atoms? The problem is this word, gas. Not all the group 17, they are gas. Group 17, you have gas, you have liquid, and you have solid. Okay, group 17, we have gas. For example, chlorine, greenish yellow gas. We have liquid, Bromine is a brown liquid. We have solid. Iodine is purplish black solid. So not all the group 17 they are gas. So that's why answer donkey is wrong. Yeah. So next one, which element does not dissolve in water to form a solution to change the blue litmus paper to red, then decolorize? So you see, when you see litmus paper and decolorize, it means it's bleach. Okay. So when they ask does not means what? Not a bleach. Okay, not a bleach. So who is bleach? Confirm chlorine and bromine, they are bleach. Chlorine and bromine, they are bleach. So what about fluorine and iodine? Okay, so we know that this is fluorine, chlorine, bromine, and iodine. Going down the group, it become less and less reactive. It become less and less reactive. So if chlorine is a bleach, bromine is a bleach, fluorine is a bleach or not. So going down the group, it become less reactive. Going up the group, it become more reactive. So we know fluorine is more reactive than chlorine. So if chlorine is a bleach, fluorine also a bleach. Okay, because remember, fluorine, F is more reactive than Cl. So if F is more reactive, which means what? If Cl can be a bleach, F also can be a bleach. Okay, but when you're going down the group, it becomes less and less reactive. So iodine is not so reactive already, so it cannot be a bleach. So the answer, it is donkey. Okay, it is D. Yeah. Okay, so let's go on. Okay, all right. So Q is an element in group 17. Okay, Q is an element in group 17 and its proton number is 9. So which one is true about Q? Okay, so the question told us that Q is in group 17. So answer A saying that Q exists as monoatomic gas. Wrong. When you see monoatomic gas, is referred to group 18. When you see the word monoatomic, is group 18. When you see the word diatomic, is group 17. So you have to be very, very careful. When you see the word diatomic, then only is group 17. Monoatomic is referred to group 18. So these are some keywords that you need to know. Alright. So Q is less electronegative than iodine. So how to know Q is more or less electronegative? Okay. So you see, they told us that the proton number is 9. So when proton number is 9 means what? Q, the electron arrangement is 2.7. So who has the electron arrangement 2.7? Okay. So we know that 2.7 is actually fluorine. Okay, 2.7 is fluorine. Remember this. Okay, so this is something that we learned. Okay, so let me scroll down first. Okay, let me scroll down first. Okay, so when we have 2.7 is fluorine, so add one more circle, 2.87 is chlorine. Add one more circle, 2.8, 7 it's bromine. Add one more circle, 2.8, 7 is iodine. So since now they told us the proton number is 9, so it is 2.7, it is fluorine. Okay, so now they say that Q is less electronegative than iodine. So this is iodine, is here. Okay, so how to know who is more or less electronegative? So electronegative means what? The ability to receive electrons. So you ask yourself, F and I, who can receive electron easily? Who can receive electron more easily? F is 2.7, so you have 2 shells. Okay, so this is F. For the I, you have 2, 8, 18, 7, so you have 5 shells. Okay, so which one can receive electron more easily? I would say F, because why? The electron is very close to nucleus. So when electron is very close to nucleus, this pulling force is very strong. So F can receive electron more easily. if you compare the iodine, the electron far away from nucleus. When electron far away from nucleus, the pulling force is very weak. So when pulling force is very weak, it's very hard to receive electron. Okay, so now you know already F can receive electron more easily. So F is more electronegative. Okay, so F is more electronegative. So now the Q is actually our fluorine, right? Just now I said the Q is what? The substance Q, we already find out is fluorine. Okay, so the Q, which is the fluorine, is less electronegative than iodine. This is wrong. Okay, so by right, we know the Q is fluorine. Fluorine can receive electron more easily than iodine. So when fluorine can receive electron more easily, fluorine should be more electronegative. Okay, so next one, Q has a higher boiling point than chlorine. Okay, so we know the Q is the fluorine. So Q is actually our fluorine. So and then they ask us to compare with chlorine. Where is chlorine? Chlorine is below the fluorine here. Okay, so we know going down the group, what happened to the melting point and boiling point? Increases. Going down the group, melting point and boiling point increases. So your Q is your fluorine. Since the fluorine is higher than the chlorine, since the fluorine is higher than the chlorine, so the melting and boiling point should be lower, because because we know fluorine has a smaller size, right? When fluorine has a small size compared to chlorine, chlorine has a bigger size. Okay, so when the size of the fluorine is smaller, the van der Waals force is weaker. So when the van der Waals force is weaker, so we need less heat. So less heat means the melting boiling point should be lower. So but they say higher, so it's wrong. So the answer should be donkey. Q can react with sodium to form a compound which is NaQ. Okay, so this is true because we know when halogen react with, okay, when the so because why? We can use chlorine to predict. Okay, we try to use chlorine to predict. So chlorine combined with sodium, you form sodium chloride, right? We know chlorine can combine with sodium to form sodium chloride. So you change the chlorine here, become Q. So here the Na, you keep it, the Cl become Q. So NaQ, correct. You can use chlorine to do the prediction. You can use your chlorine to do the prediction. Okay, so the answer donkey is correct. Yeah. So the next question is very straightforward. Which of the following exists as greenish yellow gas? So greenish yellow gas is chlorine. So this is very straightforward. Okay, you know the color, then it's easy. Okay, so the next one, halogen has low melting point because of what? Okay, because of what? All right, so whenever you want to explain about melting point and boiling point, you need to talk about force, you need to talk about heat. Yeah, when you want to explain about melting point, boiling point, we need to talk about force and heat. So answer A, don't have force, don't have heat, wrong. Answer B, they don't talk about force, they don't talk about heat, wrong. Answer C, there is a force, maybe. Answer donkey, there is a force, maybe. Okay, all right. So how to choose answer C and donkey? All right, so answer donkey is the force between nucleus and the valence electron. So nucleus and valence electron, the force is called nuclear attraction. Okay, nuclear attraction. And nuclear attraction is not used to explain about melting point, boiling point. Okay, remember this. Nuclear attraction is always used to talk about reactivity. So nuclear attraction we use to explain about reactivity. Okay, so it's not melting point, boiling point. Yeah, so the best answer should be C. Okay, should be C. All right, so the next one, the density of halogen increases going down the group because of what? So we know density is equal to mass over volume. Okay, so going down the group, the size become bigger. When the size become bigger, volume will increase. Okay, when the size become bigger, it will become more and more heavy. The mass will increase. But everyone need to understand, mass increase faster than volume. Mass increase a lot, volume increase a little bit only. So we just focus on mass. So the mass will increase. So the answer is donkey, the increase in relative molecular mass. Because when the mass increases, your atom become heavy. When the atom become heavy, the density will increases. Okay? So next one. Which of the following, they are the similar properties? Okay, they want chemical properties for chlorine, bromine, and iodine. So what is the chemical properties for group 17? Number one, they react with water to form two acid. Yes, okay, group 17 can react with water to form two acid. That is correct. Number two, group 17 can react with hot iron to form iron halide. Okay, they will form iron halide. So this is correct. Okay, because we learned this in the last lesson. Okay, we learned this in the last lesson. When group 17, okay, react with the iron, you form iron halide. Okay, so by right they should write iron 3 halide. They didn't put the Roman number 3, but it's okay. Yeah, at least you see the word iron, you see the word halide. Yeah, so correct. Number 3, they react with sodium hydroxide to form two salts and a water. So this is also correct. Okay, because you see, recall back. Okay, when halogen react with sodium hydroxide, it will form two salts and one water. So this is correct. So answer number 4, the reactivity increases going down the group. This is wrong. For group 17, going down the group, it becomes less and less reactive. For group 17, going down the group, it becomes less and less reactive. Okay, only group 1 going down the group, it become more and more reactive. Okay, so the 4 is wrong. So 1, 2, 3 only. So the answer is A. Yeah. So now we need to look at another question. So let's look at the subsequent one. So the reactivity for group 17 decreases down the group. Okay, group 17 decrease down the group, the reactivity. Why? Okay, so this question is very straightforward. Okay, so going down the group, okay, going down the group, we know the atom become larger and larger. When the atom become larger and larger, the electron now is far away from the nucleus. Okay, so the electron now far away from the nucleus. So when electron far away from nucleus, the nuclear attraction become weaker. Okay, when nuclear attraction become weaker, it become harder to receive electron. Yeah, when the pulling force become weaker, it become harder to receive electron. So how are we going to choose the answer here? Okay, all right, how to choose the best answer here? All right, so the answer is B. The attraction between the nucleus and the valence electron decreases. Okay, going down the group, electron far away from nucleus, so the nuclear attraction become weaker. So when the nuclear attraction become weaker, so the attraction decreases. So the answer is B lah. Yeah, B is the best answer in this question. Okay, so next one, halogen, they have same chemical properties because of what? So we learned this before. So always remember, chemical properties is always decided by valence electron. Okay, chemical properties is always decided by number of valence electron. So all the group 17, they have same chemical properties because they have same number of valence electron, which is 7. Okay, so please remember, this is a very simple, very straightforward question. Okay, so all the substance in the same group, they have same number of valence electron. Because they have same number of valence electron, they have same chemical properties. Okay, so chemical properties is always decided by number of valence electron. Okay, so the next question, this is a good question. This question will ask you to do prediction. Okay, the next question, they ask you to do prediction. Okay, so they say astatine is a group 17 element and is below iodine in the periodic table. So we know group 17 we have fluorine, chlorine, bromine and iodine. So now the question tell you there is another one substance called astatine. Okay, so which one is correct? So we need to do prediction. So going down the group, astatine is less reactive than iodine. This is correct because we know group 17 going down the group, it become less and less reactive. So this is correct. Okay, astatine is lower than iodine, so astatine is less reactive. So answer 1 is correct. Answer 2, astatine exists as solid at room temperature. This is correct also. Why? Fluorine is a gas, chlorine is a gas, bromine is a liquid, iodine is a solid. So when iodine already solid, astatine must be a solid already. Okay, so answer 2 is correct. Answer 3, astatine is very soluble in water. So this is wrong. Going down the group, it becomes less and less reactive. So when it's less reactive, it's very hard to react with water. When it's very hard to react with water, solubility should decreases. It should become less and less soluble. It should become less and less soluble. And we learned this in the last lesson, you see. Okay, when we come to iodine, remember this, when iodine put in water, only a small amount of the iodine dissolve. So which means what? Iodine already very hard to dissolve. So if you going lower than iodine, okay, if you go lower than iodine, it should be even harder to dissolve. Okay? It should be even harder to dissolve. So answer 3 is wrong. Answer number 4, the atomic size of iodine is smaller than astatine. This is correct because we know iodine is here, astatine is here. Going down the group, the size will become larger and larger. So astatine should be larger than iodine. So in the other word, iodine is smaller than astatine. So it's correct lah. Okay, because we know iodine has lesser shell because iodine is here. So when we have iodine, okay, so this is iodine. So iodine we know is 2, 8, 18, 18, 7. So it has 5 shells already. But we know according to periodic table, astatine is even lower because the question tells us astatine is even lower than the iodine. So when astatine is lower, so you should have more and more shells, right? Fluorine, chlorine, bromine, iodine, and this is astatine. So when astatine is lower, you should have 1 more shell compared to iodine. So astatine is larger, so the iodine is smaller. So that's why iodine is smaller is okay. So the final answer 1, 2, and 4. So best answer goes to B. Okay. Alright, so this is how it works. Okay, so these are all the objective questions. So I hope you can understand. Okay, you can understand how we solve all the objective questions. Okay, so we must really understand the concept. Okay, the concept, the pattern in your group 17. Okay, how the question can be tested. Okay, for your group 17. Yeah. Okay, so now we will proceed with the subjective question. Now we will try to do some subjective question. Okay, all right, so let's try to do this. Okay, so this is a SPM past year. Okay, this is SPM past year in the year of 2012. All right, So the diagram 3 show you a part of the periodic table. So the question A asks, what is the basic principle we use to arrange the element in the periodic table? So they didn't ask about group, they didn't ask about period. They just asked you the basic concept in the periodic table. So we learned this in lesson number 1. Okay, we learned this in lesson number 1. So in periodic table, we arrange the substance by using increasing proton number. Okay, in periodic table, we are using increasing proton number to arrange the periodic table. Okay, so you can say increasing proton number. If you don't want to use the word proton number, you also can use the word atomic number. Also can, yeah. Proton number and atomic number is actually the same thing, yeah. All right. So next one, you need to mention two elements that are in the same period. So we know this is group and this is period. So the one in the same period should be these two, Na and Mg. Okay, so it can be Na and Mg, it can be Na and Cl, it can be Mg and Cl, up to you. As long as these three substances, you choose two of them, okay? Because both of them, they are in period number 3. This is period 1, this is period 2, this is period 3, okay? So any two lah between Na, Mg and Cl. So let's say I choose Na and Mg, okay? Let's say, yeah? So write the electron arrangement for chlorine atom. So chlorine atom, so if you are fast, you can write the electron arrangement yourself. Chlorine is 287. Chlorine is 287. If you're not sure, there's another way to do. If you're not sure, another way to do is this. Chlorine is in group 17, so you know it has 7 valence electron. Chlorine is in period 1, period 2, and period 3. Period 3, which means chlorine should have 3 shells. So chlorine should have 3 shells. And we know that it is in group 17. So group 17 should have 7 valence electron. Then you try to make it full. First shell, you can put 2 electrons to make it full. Second shell, you can put 8 electrons to make it full. So it's 287. Okay, it's 287. Okay, so that is the electron arrangement for chlorine. Yeah. So next one. So the question say the molecular size of chlorine is smaller than the bromine. So why the melting point and boiling point of bromine is higher than chlorine? Okay, so the question give us 2 marks. So when you want to explain about melting point, boiling point, you must talk about the force and the heat. So we know the bromine has a larger size than chlorine. So when bromine has a larger size, it means that bromine has a stronger force, right? So when bromine has a larger size, so compared to the chlorine, chlorine has a smaller size. So bromine should have a stronger van der Waals force, okay? Alright, so you can just mention, alright, so the bromine molecules attracted, okay, the bromine molecule attracted by a strong, okay, by stronger van der Waals force, okay? So if you don't want to use the word van der Waals force, you also can write intermolecular force. It's acceptable, okay? It's acceptable. Because bromine has a larger size, bromine has a stronger van der Waals force. So because bromine has a stronger van der Waals force, you need more heat, okay? More heat is required, okay? More heat is required, okay? So we need more heat for what? To overcome the force of attraction, okay? So we need more and more heat to overcome the force of attraction, okay? So this is how we answered it, okay? Alright, next one. Magnesium react with oxygen to form magnesium oxide. So they asked us to write the chemical equation, okay? So let's try to write the chemical equation. Magnesium, the formula is Mg. It reacts with oxygen. So we know oxygen is a gas. Most of the gas come in two. Most of the gas come into oxygen gas is O2. It's not O only, it's O2. So after they react, they form magnesium oxide. So magnesium oxide, what is the formula? So you can predict, okay, the formula by the charge. So we know magnesium oxide. So the charge of magnesium is Mg 2 plus. Oxide, the charge is O2 minus. So when the charge is the same, Form 4 Chapter 3, when the charge is the same, we cancel the charge and then we join them together. So when magnesium join with oxygen, you get MgO. Yeah. Then after that, you must make sure the equation is balanced. Okay. So we need to balance the equation. 2 oxygen on the left, 2 oxygen on the right. So when we have 2 magnesium on the left, we put 2 magnesium on the right. Okay. So now this is how we balance the equation. Okay. So next one, they ask us about the color for magnesium oxide. So do we learn about the color for magnesium oxide? No, we didn't. But I can teach you a simple way to do it. Okay, a simple concept for you to know. All right. So magnesium oxide, magnesium is metal. So all the metal oxide, okay, when you see metal combined with oxygen, they are metal oxide. So the metal oxide is white color. Okay, the metal oxide is white color. We learn this in group 1. Okay, we learn this in group 1. When we learn in group 1, it react with oxygen, it will form a metal oxide. And we know metal oxide, the color is white. That's it. Okay, so remember this. When we have metal combined with oxygen, we will get metal oxide. Metal oxide, the color it is white. Okay, it is white in color. That's it. Okay, so this is how we do the question. So this is the real SPM past year question. So if you can do this question, okay, from the top to the bottom, then you will get 7 marks. If you can do the whole question, then you can get 7 marks from this question alone. Yeah. Okay, so now we will continue a little bit more with the next question. All right. So this is another past year question. So the question say that diagram 2.2 shows the apparatus for 3 different experiments. So we need to tick the correct apparatus for the reaction between chlorine and hot iron wool. Okay, so how are we going to do it? Okay, so among these 3 diagrams, which one is correct? I would say it's the last one. Why? When chlorine gas go in, it will react with the hot iron wool, and here you must have a soda lime. Soda lime will help you to absorb the extra chlorine gas. Why? Because all the halogen gas, they are toxic. Always remember, halogen gas, they are toxic. So if you don't have this, all the toxic gas, they will go to the surrounding, which is very dangerous. Okay, so we need a soda lime to absorb the toxic halogen. Okay, we need the soda lime to absorb all the toxic gas. So the last one is correct. So this is very straightforward lah. Okay, so next one, you need to mention the group number for halogen in the periodic table. So this is quite simple. Halogen, the group number is group 17. Halogen is referred to group 17. So now they ask us to write electron arrangement for the P and the Q. So this is quite simple. Atom P, you have 9 protons. So 9 proton is 2.7. Okay. Atom Q, you have 17 proton. So the electron arrangement should be 2, 8, and 7. So this question is very straightforward as well. Yeah, it's very straightforward. So next one, based on your answer, you need to mention which period it belongs to. So this is not very hard. We learned this in lesson number 1. Period is decided by number of shells. Okay, period is decided by number of shells. Atom P, you have 2 shells, so it's period number 2. Okay, and atom Q, you have 3 shells, so it's period number 3. So this is very straightforward lah. Okay, so next one, the number of neutron of Q is 19. So you have to write the symbol for Q in the form of X and AZ. So this is called standard representation. When you see something like this, X, A, and Z, this is called standard representation that you learn in your Form 4 Chapter 2. Form 4 Chapter 2. So this X is the symbol. This is the symbol that you need to use. Okay. So what is the symbol here? The symbol is Q. Okay. So the symbol is Q. Okay. We just put a Q in a big letter. So here you have 2 numbers. On top here you have a big number. And at the bottom here you have a small number. Okay. So if you have forgotten, please revise back your Chapter 2. Okay, so this big number is called nucleon number. The small number is the proton number. Okay, so how to get the nucleon number? Nucleon number is the proton plus neutron. Okay, so proton number is the amount of proton you have. So do we know the number of proton for the element Q? Yes. Okay, element Q, the proton number is 17. Yeah, is 17. So the proton number is 17. Put the 17 at the bottom. So the number on top here is nucleon number. So nucleon number, you must take neutron plus proton. So the neutron is 19. The proton is 17. So if you add together, is 36. Is 36. So this is the nucleon number. So many students, they just put the 19 here, which is wrong. Okay, 19 is the number of neutron, but we don't want that. We want nucleon number. Yeah, nucleon number, we take proton plus neutron. Okay, that's it. So next one, as you go down the group for the halogen, so you need to mention what is the change in the properties. So this one, just tell people about the change. No need to explain. It's only 1 mark. Okay, what happened to the size? So going down the group, the size will become larger and larger, right? The size will actually become bigger and bigger, or become larger. So you can say the size increases. You can say the size become bigger. You also can say the size become larger. No problem. Yeah, same meaning. Okay, all these has same meaning. Okay, bigger. All right, so the next one, what happened to electronegativity? Electronegativity means the tendency to receive electron. So for halogen, for group 17, chlorine, bromine, and iodine, going down the group, the size become larger. So when the size become larger, electron far away from the nucleus. So when electron far away from nucleus, the nucleus very hard to pull the electron. When it's very hard to pull the electron, okay, it's hard to receive electron. When it's hard to receive electron, it become less electronegative. Okay, it become less electronegative. So electronegativity will decreases. Okay, because going down the group, it become harder and harder to receive electron. Okay, it become harder and harder to receive electron. Yeah, that's it. So what about melting point and boiling point? Okay, for the next question, what about melting point and boiling point? So when you're going down the group, okay, 17, the size become larger, right? So going down, so this is chlorine. So going down become bromine. Okay, going down the group become iodine. Okay, the size will become larger and larger. So when the size become larger, so the van der Waals force will become stronger. So when van der Waals force becomes stronger, we need more and more heat to break it. So when we need more heat means very hot. When very hot, the melting and boiling point will increases. The melting point and boiling point will increases. Okay, that's it. Okay, so the next one. So they say iron glow brightly when react with element Q. Write the reaction. Okay, so we know the element Q is actually our group 17 substance. Okay, element Q is in group 17. So again, for group 17 reaction, always use chlorine to predict. Okay, we will try to use chlorine to predict. So I will still write iron, Fe. Chlorine is group 17. Group 17 always come into Cl2. Okay, so what happened? When iron combine with chlorine, you will form iron chloride. Okay, when iron combine with chlorine, you will form iron chloride. So we know iron can be iron 2 and iron 3. And we learned in the last lesson, when the halogen combine with iron, when halogen combine with iron, you form iron 3 halide. You form iron 3. So this one should be iron 3. Okay, so what is the formula for iron 3 chloride? So we can predict it. Iron 3, the charge is Fe 3 plus. Chloride, the charge is Cl minus. So they have different charge. We do a cross method. So this is number 3 and this is number 1. So from here we get FeCl3. Okay, so that is the formula. So now we need to balance the equation. So let us balance the equation. So you can put a 3 here and 2 here to balance it, and you put a 2 here. Okay, so after you balance the equation, then you modify. So now, do they want the chlorine? Nope, they want element Q. So you change all the Cl here, become Q will do. Okay, so you will get 2Fe, you will get 3Q2, you will get 2FeQ3. Yeah, you just change all the chlorine to become Q. Okay, that's why I say for group 17 you always use chlorine to predict. Okay, use the chlorine to predict, and after predict you copy, paste and modify. Yeah, you copy, paste and modify. That is how it works. Okay, so now we're going to move on to another one more question. So this is a question in your trial exam. This is a question came out in a trial paper. Yeah, a state paper. Yeah, so figure 1 shows the electron arrangement for 3 elements. So we have P, we have Q, and we have R. Okay, so now we need to write the electron arrangement for P, Q, and R. So this is quite simple. We just need to look at the diagram and change the diagram to electron arrangement. Okay, so for element P, it is 2.8. Okay, for element Q, it is 2.7. And for element R is 2.1. Yeah, we just need to look at the diagram and change the diagram to become electron arrangement. Next one, we need to mention the group and period for each element. So this is quite simple. For element P, the group is depends on the valence electron. Element P, we have 8 valence electrons, so it's group 18. So it has 2 shell, so it's period number 2. Okay, so group 18 and period number 2. So what about element Q? Element Q has 7 valence electron. So 7 valence electron is group 17. So it also have 2 shells, so it's period number 2. So element R, we have 1 valence electron. So 1 valence electron, it is in group number 1. It's in group number 1. Okay, group 1. So it also have 2 shell here. So it's period number 2. Okay, so this is very straightforward lah. Okay, so next one, you need to know which element is chemically inert. Inert means unreactive. So remember, okay, when the substance is unreactive, it must be stable. So to be stable, it must achieve octet or duplet arrangement. So we go to check. So these 3 substance, any substance already achieve octet or duplet? This one. So element P already achieved the octet arrangement. Okay, so you can write element P. Element P is chemically inert. Inert means unreactive. So they ask us to give a reason why. Why element P is inert, why it's unreactive already. So you need to write this. So this is how you write it. So you can mention that element P has already achieved. Okay, and learn this word is already achieved. So the first word you need to write is stable. Okay, you need to write stable. So they are already stable. Why? Why element P is stable? Because you already get the octet electron arrangement. So this is very, very important. Okay, so when element P achieve the octet electron arrangement, it is stable. So when it is stable, what happened? So it don't need to react with others. So it does not need to do three things. So when you are stable, you don't need to donate, you don't need to receive, and one more thing, you don't need to share electron. Okay, you don't need to donate the electron, you don't need to receive electron, and you don't need to share the electron, okay, with other elements, okay, with other element or other substance. Okay, so this is the answer. Okay, alright, so make sure every time when you want to explain why the substance is stable, this is how you mention. Okay, you already achieve stable electron arrangement. Since it achieves stable electron arrangement, so it don't need to donate electron, it don't need to receive electron, it don't need to share the electron. Okay, so this is why it is unreactive. Okay, it is inert. Okay, alright, so next one. Element Q can dissolve in water to form acidic solution and a bleaching agent. Write the chemical equation for element Q with water. Okay, so what is the element Q here? So we know element Q have 7 valence electron, so it is group 17. So group 17 can react with water. So remember, when group 17, when halogen react with water, you will form 2 acids. Okay, you will form 2 acids. Okay, so what is the formula here? So we can use chlorine to predict. Okay, we can use chlorine to predict. Chlorine is Cl2, so the water is H2O. So you form 2 acid. Acid always have H. So you have HCl, another one, copy back HCl, you add a O in the middle. Okay, you add a O in the middle. So this is the equation when chlorine react with water. But now this question is not asking for chlorine, they're asking for Q. They're asking for Q. So you change all the Cl here to become Q. So you get Q2 plus H2O. You will get HQ and HOQ. Yeah. So this is the tips. Always use chlorine to predict. Always start with chlorine to predict, and you modify it. Okay, and you modify to other group 17 substance such as your Q. Okay, so this is how we do it. Okay, so next one, which element they can react actively with water? Okay, so who can react with water? Okay, so in SPM there is 2 group can react with water. One is group 1 and one is group 17. Okay, because when group 1 react with water, they form alkali. Yeah, when group 1 they react with water, they form alkali. When group 17 react with water, they form acids. Okay, they form acids. Okay, so there are 2 substances they can react with water. One is Q and one is R. Okay, one is Q and one is R. Okay, so you can write Q and R. Because element Q is group 17, group 17 can react with water. And element R is group 1, group 1 also can react with water. Yeah? Okay, so next one, question F. The proton number for element X is 17. Okay, So among PQR, which elements show the similar chemical properties? So remember, chemical properties is decided by number of valence electron. Chemical properties is always decided by number of valence electron. So for element X, 17 is 287. So we know element X have 7 valence electron. So if you want to have similar chemical properties, we need to choose the substance that also got 7 valence electron. So if you look at our answer, answer Q got 7 valence electron. So this is the answer Q. Okay. So element Q got 7 valence electron, which is same as element X. So when they have same number of valence electron, they have same chemical properties, because chemical properties is decided by number of valence electron. Yeah, so this is a very important concept that you need to know. Okay, so for the next question, okay, so now you can see, so this question mentioned that sodium and also chlorine, they can react with water to form solution. Yeah, so chlorine and sodium can react water to form solution. So you need to write the chemical equation, okay, for the reaction between chlorine with water. So let's try to do it. So we want to let chlorine to react with water. So chlorine is Cl2, so it react with water. So remember, when halogen react with water, you form 2 acids. Okay, when halogen react with water, you form 2 acids. Acid always has H. Okay, so the first acid is H combined with the Cl here, HCl. Then you copy the HCl again. So now you have another acid, HCl. And in between the H and Cl, you add the O, HOCl. Okay, so this is the chemical equation. So you must always make sure all the chemical equation is balanced. So this equation already balanced. So we don't need to add any number. So next one, we need to know the color change of the litmus paper. So what is the color change of litmus paper? So let's start with the first one. Okay, the first one. So when sodium put with water, so you produce sodium hydroxide. So anything got OH is alkaline. Okay, alkaline. So makes sense because we know sodium is group 1. Group 1 is alkali metal. When we put alkali metal into water, it produces alkaline. So when we have alkaline, what we can see on the litmus paper? Alkaline, you can see litmus paper change from red color to the blue. Okay, red litmus turn blue. Okay, so that is what you can see. Okay, so remember, group 1 is alkali metal. When you put alkali metal in water, you produce some alkaline solution. Alkaline solution can change the litmus paper from red to blue. Okay, what about chlorine? So we know when chlorine put in water, you produce 2 acids. So when you have acid, you can see the blue litmus paper. Okay, when we have acid, the blue litmus paper will turn to red. And don't forget, chlorine and bromine, they are bleaching agent. Chlorine and bromine, they are bleaching agent. So after the litmus paper turn to red, it will then bleach to white. Okay, so when we have chlorine and bromine dissolved in the water, we will produce acid and bleaching agent. So bleaching agent can decolorize the litmus paper. It can make the litmus paper all the color gone. It can make all the color fades away. Okay, so to become white color. Yeah, so this is what we need to know. Okay, so now we are done with this question already. Okay, next one. So this is another past year question. Okay, all right. So this is not a past year question. This is another trial exam question. So this is a trial exam paper. So you need to use the letter to answer the question. So the first one, we need to write the electron arrangement for atom D. So before we draw the electron arrangement, I think it's better for us to write the electron arrangement first. So how to know the electron arrangement for atom D? You need to check two things. The first thing, you check the period. Atom D is in period number 2. So when atom D is in period number 2, it means that you have 2 shell. Okay, you have 2 numbers. Then if you check the group, atom D is in group number 13. Okay, atom D is in group 13. So group 13 means that it has 3 valence electrons. So when you are in group 13, you have 3 valence electrons. So now we know the valence electron should be 3. Okay, so the first shell, to make it full, we put 2 electrons. So it's 2.3. Okay, so 2.3 is the electron arrangement. So now we want to draw it. So how to draw it? Okay, so first of all, we must draw 2 shells. So 1 and 2. Okay, 2 shells here. So the first shell got 2 electrons. The second shell got 3 electrons. So how to put 3 electrons? 1, 2, and another one you can put here, or you can put here. No problem. Okay. And don't forget, you need to draw another small circle, which is nucleus. You need to draw a circle. This circle, don't put any electron. This is nucleus. Okay. Then you can put the symbol D here. Okay. You can put the D inside. Okay, so this is the electron arrangement for the atom D. Okay, so then we continue. Now the question asks, which element is monoatomic gas? So when you see monoatomic gas, it's always referred to group 18. Okay, when you see the word monoatomic, so it's group 18. So who is in group 18 here? So this is group 18, which is A. Okay, so you must put A. So you cannot go to put helium, neon, or argon, because you must refer to the symbol given. Okay, you must use the symbol they give you. Okay, all right. So which is substance A. Okay, next one. Which element exists as diatomic molecule? So when you see diatomic, it's always referred to group 17. Okay, when you see diatomic, it's referred to group 17. Okay. So you go to check who is in group 17 here. So the group 17, you have substance T. Okay, so just put T. Okay. So next one. Which element is halogen? Halogen is group 17. So group 17 is substance T as well. Okay. So this question is very straightforward. Okay. So this is one of the very popular way they can ask you the question in your exam. In exam, for this chapter, okay, for periodic table, they will always give you a periodic table. So they will give you one portion of periodic table, and they want you to answer the question by using the periodic table they gave you. Okay, they want you to use the periodic table they gave you to answer the question. Yeah, that is how it works. Okay, so we continue a little bit more. So next one, same thing, you see, this is another question. As you can see, they give you the periodic table with the symbol, okay? So now you need to use the symbol to answer the question. So the first question, they ask you to choose one letter or one element that can react with cold water, okay? So the water, no matter cold or hot, doesn't matter. Most importantly is water. So who can react with water? Okay, group 1 and group 17. Okay, group 1 and group 17 can react with water, because for group 1, when we have alkali metal react with water, you will produce alkali and you will have hydrogen gas. Okay, for group 17, when we put halogen in water, okay, when we put halogen in water, you will produce 2 acids. Okay, so group 1 and group 17, they can react with water. So here you have 4 possible answer. It can be, so who is in group 1? A or B. So your answer, you can write A, you can write B, no problem. You also can go for group 17. So if you go for group 17, which is here, so it can be E or H. Okay, it can be E or H. Okay, so it really depends on which one you choose. Okay, so you have 4 possible answer. You just need to give one of it. You just give one of them. Okay, so next one, you need to tell whether the solution you form is acidic or alkaline. So this one depends on which answer you choose. If you choose answer A and B, if your answer is A or B, A and B is group 1. Group 1 is alkali metal. So when alkali metal put in water, you form alkali. Okay. So if your answer is this, okay, so it depends on your answer. So if the answer is A or B, okay, if the answer is A or B, then it is alkaline. Okay, so this is alkaline. Okay, if your answer is A or B, okay, and the answer can be acidic. Okay, if your answer, okay, if your answer you go to choose, okay, E or H. Okay, when you choose E or H, is halogen. Halogen can react with water to form acids. Okay, so it really depends on which one you choose lah. Okay, it depends on which one you choose lah. Okay, so now you need to write the chemical equation for the element A1 with the water. So it depends on which one you choose. Okay, if it depends on which one you choose. If you choose the element A or B, how to write? Okay, how to write the chemical equation when you have group 1 to react with water. So group 1, you can use sodium to predict. If you have group 1, you can use sodium to predict. So group 1 is sodium. So it react with water. So it will form alkali. Alkali must have OH. So alkali has OH. So when you put sodium, the alkali is NaOH. And don't forget, you produce hydrogen gas. Okay, so to balance the equation, you can put a 2 here. Okay, so now the equation is balanced. Then only you can modify the Na here with the symbol A or the symbol B. Okay, you can modify the Na with A or B because the alkali metal they give you is A or B, which means your final answer, okay, your final answer, you can write something like this. Okay, you can write, okay, 2A plus 2 water to become 2 AOH plus H2. You also can write 2B plus 2 H2O to become 2 BOH plus H2. So this is one of the answer you can give. Okay, so if you don't want to do this, also can, you can go for E or H also can. If you choose E or H just now, then it's different because E and H, they are group 17, which is halogen. So when halogen react with water, what to do? So when you want halogen to react with water, you can use chlorine to predict the equation. So we use chlorine to predict. So when chlorine react with water, you will form 2 acids. So acid always have H. So the first one is H combined with the Cl, HCl. The second acid is H and Cl, and in between you add the O, HOCl. Yeah. So this is another equation. So now what you need to do is this. So now you can just modify, yeah, you can just modify the whole thing accordingly. Yeah, you can modify the Cl here to become other halogen. Okay, you can modify the Cl with other halogen. So the halogen they give you here, it's actually E or H. Okay, so you can change the Cl with E or H. So if you change the Cl with E, it become E2 plus H2O become He and HOE. Or you can change the Cl become H. H2 plus H2O to become HH and HOH also can. Yeah. So it depends on which answer you choose. Okay, so you have 4 possible equation here. You just need to write one of them. Yeah, just write one of them will do. Yeah. Right. So let's say I write one for the acid and one for the alkali lah. Let's say I choose the A. When A react with, okay, the water, okay, when the A react with the water, so you form A, OH and H2. Okay, then I give another one more answer for the alkaline. Okay, so you see this one also can be B. 2B plus 2H2O become 2BOH plus H2 also can. Yeah, so you have many answer. Okay, so if you choose the E or H, just now I show you when E plus H2O, so you're gonna get HE and HOE. So if you choose the H, and don't forget halogen is E2, okay, so when you choose the H, so the formula here is HH and HOH. So don't memorize all these equations. Okay, don't memorize it. Try to understand the concept and write all these equations on your own. Yeah, try to create this equation yourself. Don't memorize it. Okay, next one, we need to give the number of valence electron for atom G. So let's look at the atom G here. So where is atom G? So atom G, it's here, which is the last group. So atom G is in group 18. So we know the last group is group 18. Group 18, the valence electron is 8. You have 8 valence electron. Next one, you need to give the use of element F. So we need to know who is element F first. So if you look at it, element F is in group 18. We know group 18, the first member is helium. The second member is neon. The third one is argon. Yeah, we need to know the first 3 members in group 18. So the F is actually neon. So, and we learned before in the group 18. So what is the function of neon? So where we can use neon? Neon can use to fill up the advertising board, or advertising light. Okay, is used to fill up the advertising light. Okay, so advertising light inside, we go to put in some neon. Yeah, all right, so that is what we need to do. Okay, so you see this question is not only asking for group 17. They can combine the question to ask you something about group 1, something about group 17, something about group 18. Yeah, they can combine everything in one question. Okay, so now let's move on to one more question. This is a real SPM past year. This is a past year question in the year of 2005. This is SPM past year 2005. Okay, so let's do this question. So the question says figure 1 show you the part of the periodic table. Okay, so they give you a periodic table, and the first question want you to choose halogen. So this is quite simple. Halogen is group 17. So if you look at it, where is group 17? The second last group from the back. So this is group 17. So who is inside the halogen? The substance Y. Yeah, so we just put the letter Y. Yeah, we just put in the letter Y will do. Yeah, very straightforward. Next one, we need to write the electron arrangement for the atom of element Q. So how to write electron arrangement for the Q? Okay, so let's look at where is the Q. So this is Q. So how to write electron arrangement? So we can check the period and the group. So this is the first period and this is the second period. So Q is in period number 2, which means that Q should have 2 shell. So you have 2 number, yeah, shell number 1 and shell number 2. Okay, so after that we need to check the group. So if you count the group, okay, you can count backward if you want. Okay, if you want, you can count backward or you can count forward also can, no problem. Okay, so this is 18, 17, 16, 15 and 14. So this is group 14. So element Q is in group 14. So group 14 should have 4 valence electron. Okay, group 14 should have 4 valence electrons. So the valence electron should be 4. Okay, so now the first shell, to make it full, we just put 2 electron will do. Okay, first shell only need 2 electron to be full. So the electron arrangement is 2 and 4. Yeah, so we just write 2 and 4. That's it. Okay, so next one, we need to write the formula for the ion that is formed for the atoms of element Y. Yeah, so for element Y, so we need to try to solve the questions here. Okay, we try to solve the question. Okay, so now, all right, what we need to do is this. Okay, so what is the formula of ion? Ion means what? Ion means charge. Okay, so what is the charge for element Y? So look at element Y. Element Y is in group 17. Okay, always remember, group 17, they have 7 valence electron. Group 17, they have 7 valence electron, so they are not stable yet. So in order to be stable, group 17, they will receive 1 valence electron. Okay, group 17 always receive 1 valence electron to be stable. So they get 8 valence electron. So when they get 8 valence electron, is octet. So they are stable. Yeah. So when a neutral substance receiving electron, it always become negative ion. Always remember, when you have a neutral atom, when the neutral atom donate electron away, so you will produce positive ion. When a neutral atom receive electron, so you will produce negative ion. So group 17, they will receive 1 electron to be stable. So when they receive 1 electron, so you will get the negative ion, and the charge is -1. Yeah. So the formula is Y negative. Okay. All right. So if today, let's say today you are in group 16. Group 16, you have 6 valence electron. So in order to be stable, you will receive 2 more electron. So when you receive 2 electron, so the charge will be 2 negative. Okay, always remember, when you receive electron, you will get negative charge. You receive how many electron? The negative charge will follow. If you receive 3 electron, it will be 3 negative. You receive 2 electron, 2 negative. That's it. Okay, so group 17, they will receive 1 electron only. So when you receive 1 electron, the charge is -1. So you don't need to write -1 like this. In chemistry, 1 no need to be written. Yeah, you don't need to write the number 1 here. So don't need to write the number 1. So the charge is Y minus. Okay, so that is the formula of the ion. Yeah, all right. So next one, the question is asking why element Q and R, they are placed in the same period. So this is something we learned in the first lesson. Okay, so why they placed in the same period? Period decided by number of shells. Okay, so if you look at Q and R, so Q and R, both of them, they are in period number 2. This is period 1, this is period number 2. So Q and R both in period number 2. Why? They have 2 shells occupied with electron. Okay, always remember, period is decided by how many shell occupied with electron. Okay, so your answer is this. Okay, so Q and R, both of them. Okay, or you can just mention, okay, they are, okay, Q and R, they have same number, they have 2 shells occupied with electrons. Q and R, they have 2 shells occupied. You can write occupied, or you can write filled with electrons. Okay, so make sure you must mention the shell filled with electron, because many students only write Q and R has 2 shells. If you write until here, it's wrong. You must mention the shell is filled with electron. Yeah, this is something very important. Okay, so next one, we need to look at the subsequent question, question F. Okay, let's look at question F here. Okay, question F. So question F, when a small piece of element T is put in water, so you will get a solution called TOH. Okay, so and hydrogen gas is released. So you need to mention what is the observation when the red litmus paper is put into the solution. Okay, what is happening here? Okay, when you see OH, you know already this is alkali. Yeah? When you see OH, this is alkali, and it's true because they're asking about element T. If you look at the question, where is element T? Okay, if you look at the question, element T, it's here. It's in group number 1. So group 1 is alkali metal. Yeah, group 1 is alkali metal. So alkali metal, they produce alkaline. Okay, produce alkali metal, they can produce alkaline solution, which is TOH. So when you have alkaline solution, what happened to the red litmus paper? So you will see the red litmus paper will turn blue. Okay, so when the red litmus paper turn blue, it proved that the solution, it is alkaline. Okay, it proved that the solution is alkaline solution. Yeah, that is what you need to know. All right, so next one. Okay, So now we're going to look at another subsequent question. Okay, so let's look at the next question. So this is MRSM trial exam question. Okay, this is a question came out in the soalan percubaan trial exam paper. Okay, so you are given diagram 7.1 show you the chlorine and iodine, okay, in the periodic table. So the question is asking which group this element belongs to and why chlorine is more reactive than iodine. 4 mark. So this is essay question. This is essay question. So when you are given 4 mark, you must write minimum 4 points. Okay? You must write minimum 4 points. Okay. So let's see how to answer it. Point number 1. Okay. Point number 1. So you need to mention the group. Okay. So which group they belongs to. So you see, chlorine and also the iodine, both of them, okay, they are in group 17. Okay, we know that chlorine and iodine, they should park under group 17. Yeah, so this is very straightforward question. This is a very straightforward answer. Yeah, this is point number 1. Okay, so point number 2. So when you want to explain about reactivity, remember reactivity, you must talk about nuclear attraction. So if you need to, maybe you can draw a diagram. So you can see chlorine, okay, chlorine we know it is 287, so the size is like this. So iodine, it is 2818 18 7. So iodine has 5 shells and chlorine only got 3 shells. So iodine should be larger than the chlorine. Okay, so first thing you can see is iodine, the size is larger than chlorine. So you can write this now. Okay, the atomic size of iodine is larger than the chlorine. Okay, the atomic size of iodine is larger than the chlorine. So when the atomic size is larger, okay, so what is happening? So what happened now? So we know that when the size is larger, the valence electron is far away from nucleus, right? You see, this one, the 7 valence electron is here, is close to nucleus. This one, the 7 valence electron is here, is far away from the nucleus. Okay, so you can just mention, all right, the okay, you can just mention, okay, why chlorine is more reactive. Okay, so they ask us to use chlorine to explain. Okay, so we go for chlorine first. Okay, so we focus on chlorine. So in chlorine, you can see the valence electron is closer to nucleus. Okay, so in chlorine, so the valence electrons closer to the nucleus. Okay, in chlorine we can see the valence electron is closer to the nucleus. So when the valence electron close to the nucleus, what will happen? Okay, when the valence electron close to the nucleus, so the force of attraction is stronger. Okay, just like this. Okay, I mentioned before, when the moon is very close to the earth, so the pulling force is very strong. Yeah, when the moon is close to the earth, so the pulling force is very, very strong. Okay, so same thing apply here. Okay, so in this case, okay, what is the name of the force? Okay, so this one is nucleus, so the nucleus pulling the electron, this attraction called nuclear attraction. Okay, this is called nuclear attraction. So you can just use the word nuclear attraction. Okay, the nuclear attraction is what? The nuclear attraction is between the nucleus. Okay, the nuclear attraction is between the nucleus and also the electron. Okay, and also electron, because we want to use the nuclear attraction to pull one more electron from outside. Okay, so you see here we have 7 electron. So we want to use the nuclear attraction. Okay, we want to use the nuclear attraction to pull one more electron from outside. So, right, when the size is small, this pulling force is strong. Okay, so this pulling force is called nuclear attraction, okay, between nucleus and the electron. Okay, nuclear attraction between the nucleus and also the electron, okay, is actually stronger in the chlorine. Okay, so in chlorine, the pulling force is stronger. Why? Because chlorine, the size is smaller, so the electron very close to the nucleus. When electron close to the nucleus, the pulling force is strong. Okay, so when the pulling force is very strong, so you can pull the electron into the valence shell easily. You see here? This is chlorine. It has 7 valence electron. So this is nucleus. So this is the electron that you want to pull. So when the nuclear attraction is strong, you can pull this electron into the shell easily. You can pull the electron into the valence shell very easily, just like the one we see in the last lesson. Okay, in the last lesson we learned how to explain about the reactivity. Okay, so if you refer back, okay, in the previous lesson we learned how to explain it. Okay, so you see, when the atomic size, so we must talk about, okay, how to attract the electron into the valence shell. Okay, so when the pulling force is strong, so it's easy to pull the electron into the shell. Okay, so when the nuclear attraction is stronger, so it is easier, okay, for the chlorine to, you can use the word pull or you can use the word attract electron. Okay, you can pull the electron to where? Okay, into the valence shell. Okay, you can pull the electron into the valence shell easily. Okay, because remember, you have 7 valence electron. Okay, when you have 7 valence electron, you need to pull 1 more electron into the valence shell. Yeah, when you have 7 valence electron, you need to pull 1 more electron into the valence shell in order to be stable. So who is pulling the electron for you? Nuclear attraction. So when the nuclear attraction is strong, it's easy to pull the electron. Okay, so for group 17, the more easy to receive electron, the more reactive it is. Okay, the more easy to receive electron, the more reactive it is. Okay, so remember, group 17, they want to receive electron to be stable. Group 1, they want to donate electron to be stable. Yeah, all right, so this is how it works. See, so you see, so I have total 4 points here: point 1, point 2, point 3, and point 4. Okay, so this is how I can score 4 marks for this question. Yeah. Okay, next one. So I was given a diagram. This is diagram 2.1. So they give you the standard representation for 3 elements in the group 17. Okay, so I was given chlorine, bromine, and iodine. So I was given 3 elements here. So the first question is asking, all right, what is represented by the number 35, okay, in the symbol here. So we know that when we have standard representation, the smaller number here is called proton number. So the number 35 here is the proton number. Okay, so you can write proton number. Okay, you can write proton number. Okay, or you can write it actually represent the number of proton in the nucleus. Okay, it actually represent the number of proton inside your nucleus. Okay, so that is the proton number. Okay, so next one, you need to mention the valence electron for bromine. So this is very simple. Bromine is in group 17. Group 17 always have 7 valence electron. Group 17, they always have 7 valence electrons. So this is very straightforward. So next one, you need to compare the size of chlorine and bromine. Okay, so how to know the size of chlorine and bromine? We need to refer to the periodic table. So we know the periodic table. The first one is fluorine, then we have chlorine, then we have bromine, and we have iodine. So going down the group, the size will increases. So the size will become larger and larger. So fluorine is here, chlorine is bigger, bromine even bigger, iodine even bigger. So as you can see, bromine is bigger than the chlorine. So you can say, all right, the size of, okay, bromine, it's larger, okay, than the size of the chlorine. Okay, so you can do this, or you can go the other way around. Okay, you also can say the size of chlorine is smaller than the size of bromine. Also can, yeah, no problem, as long as you can compare the size. Okay, as long as you can tell who has a bigger size and who has a smaller size, that is good enough already. Yeah, so now you need to explain your answer. Okay, you need to explain why. So why actually bromine has a larger size? Okay, why the bromine actually they have a larger size compared to the chlorine? Yeah. Okay, so for the next question now we need to explain. So we need to explain the answer why. Okay, normally when we want to explain the size, we just need to talk about the shell. Who has more shell? That's it. But you can see they give you 2 marks. So if they give you 2 marks, if you only say shell, there's only 1 mark. If you only say, all right, let's say, many students, they will only write this. Many students will write, okay, bromine, okay, has more shell. Okay, the bromine has more shells occupied with electrons, okay, compared to chlorine. So most of the students, they'll write this. It's correct, nothing wrong. But if you write this, you only get 1 mark. You only get 1 mark, more shell. But this question is asking for 2 marks, so we have to write another 1 more. So how to make the answer even more complete? How to make the answer even more complete? So probably you can put in the electron arrangement. Okay, so you can put in the electron arrangement. You can write chlorine has electron arrangement, okay, of 2, 8, 7, and then after that you must mention your bromine. So your bromine, your electron arrangement is 2, 8, 18, 7. Okay, that's it. So when you write the electron arrangement, then you can see already, okay, this is 3 shell and this is 4 shell. So from here you conclude that bromine has more shells than the chlorine. That's it. Okay, so this is how you get 2 marks. Not if this question only give you 1 mark, then you don't need to write this. You just write bromine has more shells occupied with electron. That is good enough already. Yeah, but because this question is giving us 2 marks, so your answer need to have 2 points. Okay, so how to give 1 more extra point? You go to write about the electron arrangement. Okay, so this is how we solve the question. Okay, so now we move on to another 1 more question. So diagram 2.2 shows the reactions when iodine dissolve in water. So they put iodine in water and they put a piece of litmus paper in the solution. So they ask you what is the observation on the litmus paper. Okay, so this is quite simple. So we know iodine is group 17, which is halogen. So when halogen, you go to put in the water, it will produce 2 acid. Okay, when halogen, you put in water, you produce 2 acid. So it is acidic. So when it's acidic, you can see the blue litmus paper will change color. So blue litmus paper, okay, the blue litmus paper will actually turn to red. Okay, the blue litmus paper will become red. That's it. Okay, so that is what happened. Okay, right, not very hard, right? So will the litmus paper bleach to white? No, because Chlorine got bleaching power, bromine got bleaching power, iodine don't have bleaching power. So iodine is not a bleach. So you cannot change the red color paper to become white. Yeah, you cannot bleach the red litmus to become white. So cannot. So just stop at here will do. Yeah. So next one, you need to explain your answer. So why the blue litmus paper turn red? Okay. So the blue litmus turn red is because when you have iodine, or so-called the group 17, when iodine go to react with water, okay, when you put the group 17 in water, so you always will produce acid. Okay, you can say you will produce acidic solution, or if you don't want to write acidic solution, you can also say it produce two acids. Okay, it produce two acids. Okay, so when group 17 put in water, they produce two acids. So that's why the litmus paper changed from blue color to red color. Okay, so this is a very straightforward question. It's not very hard. Okay, make sure you understand the concept. Okay, so now we will go for the last question. This is one essay question. So this is an essay question. Okay, this is the last question for your tutorial number 4. Okay, so diagram 7.1 shows the setup apparatus to investigate the reactivity between halogen and iron wool. So we know halogen can react with iron. Alright, so the first question is asking us, okay, to suggest the material P. What is material P? Okay, so material P, what it is? What is material P here? Okay, so material P, it should be soda lime. Okay, so remember, when we put halogen, okay, into the combustion tube, halogen is toxic. Okay, so if we have too much halogen go in, and if you don't have here, if you don't have this part, all the halogen gas go out, so it's toxic. So when there is any people inhale the halogen, so their health condition will be affected. Yeah, so cannot. So always remember, halogen gas is toxic, and we don't want to let the halogen gas to run to the surrounding. So we need somebody to absorb the extra halogen gas. So all the extra halogen gas will absorb by the material called substance P. Substance P is soda lime. Okay, the substance P is soda lime. That is the one. Okay, all right. So next one, you need to write the chemical equation for the reaction between Y2 and hot iron wool. So this question, they give you 2 marks. So in chemistry, when they give you 2 marks for chemical equation, if they give you 2 marks for chemical equation, 1 mark will be writing the equation and 1 mark is balancing. Yeah, if you're given 2 marks, 1 mark is for writing the equation, another 1 mark is for balancing it. Okay, so how to write the equation? So always remember, if you have halogen, you want to predict the chemical equation, it's advisable to use chlorine. Okay, it's advisable for you to use the chlorine to predict the equation. Yeah, all right. All right, so when you want to have a chemical equations between halogen and iron, you always use chlorine to predict. So we will use chlorine to predict the equation. Okay, so let us try to use the chlorine to predict. Okay, so how to do? So when we have chlorine, chlorine is Cl. Remember, halogen is always a diatomic molecule. Halogen is always diatomic, so you always have 2 atoms, so Cl2. So when chlorine react with iron, so what will happen? So when chlorine react with iron, so you will form iron 3 chloride. Okay, when chlorine react with iron, you form iron 3 chloride. Watch out, it's iron 3, not iron 2. So it's iron 3. So what is the formula for iron 3 chloride? Iron 3 is Fe 3 plus, chloride is Cl minus. So when they have different charge, we can do a cross method. When you do a cross method, the formula is FeCl3. That's it. Okay, so when you write the equation now, you can balance the equation. So you have 2 chlorine and 3 chlorine here, make it become 6. 2 and 3 make it become 6. 2 times 3 to become 6. 3 times 2 to become 6. So by putting a 3 and a 2 here, now you have 6 chlorine on the left and 6 chlorine on the right. So what about iron? Iron, you have 2 iron on the right. So you have 1 iron on the left. So you put a 2. Okay, so now you already have a balanced equation. Then only you copy, paste, and you modify. Okay, so how you modified it? Okay, so now they want to ask us the reaction between Y2. So you change the Cl to become Y. Just change the Cl become Y. That's it. So your final formula is 3Y2 plus 2Fe to become 2FeY3. Yeah. So this is how we write the chemical equation. Yeah, this is how we get the chemical equation without memorizing. So I do it step by step. I predict the chemical equation. Okay, I predict the equation rather than memorize it. Okay, so now let's move on to the last one. So now the table 7.2 show you the observation when halogen Y2 and halogen Z2, they react with hot iron wool. Okay, so now as you can see, halogen Y2 burn brightly. So halogen Z2 glow dimly. So from here you know already, burn brightly, this is reactive, and glow dimly is less reactive. Okay, so the question asks you to compare the reactivity. So who is more reactive? Okay, and they ask you to explain your answer, and the total mark allocated is 5 marks. Okay, so you are given 5 marks for this. Okay, so how to get the 5 mark here? So we have to answer it one by one. First of all, we must compare the reactivity. So we need to mention who is more reactive. Okay, so the first one, as you can see, the Y2 burn brightly. So the Z2 glow dimly. So you can see already which one is more reactive. So I will say Y2 is more reactive, okay, than your Z2. Okay, the Y2 is more reactive than the Z2. So this is point number 1. Okay, you compare the reactivity first. So then you need to start to explain. You need to explain. So how to explain about reactivity? So reactivity must talk about nuclear attraction. You must talk about nuclear attraction. And we know that for halogen, okay, chlorine, bromine, iodine, fluorine, going down the group, it becomes less and less reactive. So since you can see the Y is more reactive than the Z, so you can expect Y should be on higher position in the group 17 and Z should be lower, right or not? Because group 17, higher is more reactive, lower is less reactive. So we know element Y is more reactive than element Z. So element Y should be higher than element Z in the group 17. So now, since we know Y is higher than the Z, so you know the size already. Okay, so the Y should be a smaller size, the Z should be a bigger size, right? Okay, it should be the Y has a smaller size and the Z has a bigger size. Okay, so you can just mention this. Okay, you can mention the atomic size of, okay, the atomic size of Y is smaller than the Z. Okay, the atomic size of Y is smaller than Z. Okay, you mention the Y has a smaller size than the Z. Okay, then you can continue to explain. So when the size is smaller, so what? Okay, we know when the size is smaller, so the valence electron are very close to nucleus. You see, all right. So when the size is small, all the valence electron is very close to nucleus. When the size is big, the valence electron is far from nucleus. Okay, so you can just mention, all right, in what? Okay, so you can see that, all right, the valence electrons are, okay, the valence electrons they are closer to the nucleus. Okay, the valence electron, they are closer to the nucleus in which substance? In your substance Y. Okay, in the substance Y. Okay, because we know Y has a smaller size. So when the size is smaller, so the valence electron is closer to the nucleus. When the size is bigger, the valence electron is far away from the nucleus. Okay, so in Y. Yeah. So after that, you need to mention what? Okay, after you mention the valence electron, then you need to mention about nuclear attraction. So now you need to talk about nuclear attraction. Okay, so nuclear attraction between what? Remember, for group 17, you need to receive one electron to be stable. So you need to let the nucleus to pull one extra electron from outside. Okay, you need to let the nucleus to pull one extra electron from outside. Yeah, so now when the size is smaller, so the pulling force between the nucleus and the electron is stronger. When the size is bigger, the pulling force between nucleus and electron is weaker. Okay, so let's write it. Okay, so how are we going to write this? Okay, so nuclear attraction. Okay, so the nuclear attraction, all right, okay, between nucleus and electron. Okay, no space, I just put the short form here, E minus lah. But in exam you cannot write E minus, you have to write electron. In exam you have to spell the name electron. Okay, so nuclear attraction between nucleus and electron, okay, is stronger. Okay, the nuclear attraction is stronger in the element Y. Okay, in element Y. Okay, in element Y there is a stronger pulling force. Okay, because it has a stronger pulling force, so the Y can attract the electron more easily. Okay, you can attract electron into the shell more easily. So let me clean some space. Okay, so your element Y can attract, or you can write pull, electron, okay, into the valence shell more easily. That's it. Okay, so when the element Y can receive electron more easily, it is more reactive. Okay, so this is how it works. Okay, so this is how it works. Okay, so when the first, so you have total 5 points here. Okay, for first point you compare and you tell who is more reactive. Okay, so the first point you need to mention who is more reactive. So you can see halogen Y2 is more reactive than halogen Z2. Okay, so 1 mark. So then the next thing you have to mention Y, so the size. Okay, so how to know who has a bigger size and smaller size? So you have to arrange your group 17. So we know group 17 going up is more reactive, going down is less reactive. So element Y is more reactive, so it's higher than element Z. So when you know the location, then you agak know the size already. Okay, so going down the size become bigger. So we know that the atom Y, the size will be smaller. Okay, so we just write atom Y, the size is smaller than atom Z. Okay, so when the size is smaller, the valence electron is very close to nucleus. So that's why we write valence electron is closer to the nucleus. So when a valence electron is close to the nucleus, the pulling force is very, very strong. Yeah, the pulling force is strong. So the nuclear attraction is stronger in Y. So here I should write stronger. Sorry, I should write stronger. Okay. So when the nuclear attraction is stronger, so the Y can attract electron easily. Okay. So group 17, the more easy to attract, to receive, or to gain electron, the more reactive it is. I repeat, group 17, they want to receive one valence electron to be stable. The more easily the electron to be received, the more easy to receive the electron, the more reactive it is. Okay, so group 1, terbalik. Group 1, they want to donate electron to be stable. The more easy to donate electron, the more stable it is. Yeah, all right. So that is what you need to know. Okay, so that's it. So I hope all these exercises give you some rough idea, okay, how the question can be tested for your group 17 for objective question, for subjective question. So subjective question, they can ask for structure. These are structure question. Okay, these are the structure question. They can also ask you like essay. Yeah, these are the essay question. So the essay question is like this. Okay, so this is the essay question, and this one also the essay question. Okay, all right. So I think that's it. So hopefully you learn something from this tutorial number 4.